Assalamualaikum warahmatullahi wabarakatuh. And hello, sir. How are you? Let me introduce myself first. My name is Ahmad Akif Farhan bin Muhammad Yuzi, and my metric number is 2019-276356. And I am from class PEE 1122A2. I'm presenting this video individually without any group members. So today, I will be presenting to you one of the application of differentiation that I have learned from you on the previous class, and I have created a few questions to be discussed today, and I will show you how I solve the questions step by step. So without further ado, let's go. Applications of differentiation. In our daily life, there are actually many types of differentiation techniques that we can apply to solve a problem. For example, I have selected one of them here, which is related rates, or we can call it as rate of change. So, what is rate of change? We have seen that for quantities that are changing over time, the rates at which these quantities change are given by derivatives. If two related quantities are changing over time, the rates at which the quantities change are related. For example, if a balloon is being filled with air, both the radius of the balloon and the volume of the balloon are increasing. Moving to the next slide, what is actually differentiation? Differentiation means ratio of rate of change between two variables, in which the variable in numerator is dependent on variable in denominator, and this change is instantaneous and very small. When do we apply differentiation? Usually we apply differentiation to determine if a function is increasing or decreasing. A function is increasing if its derivative is always positive. A function is decreasing if its derivative is always negative. Next, what are other applications of differentiation? Some other application of differentiation is like linear approximation. A linear approximation is an approximation of a general function using a linear function. Next is maximum and minimum values. Maximum and minimum are critical points on graphs and can be found by the first derivative and second derivative. I have created a problem statement with a few questions to be solved. Akif cooks soup to feed his ill brother. He pours the soup into a hemisphere bowl with a radius of 30 cm and the volume is given by V equals to 1 over 3 pi 36x squared minus x cubic, where x is the depth of the bowl. For the first question, if Akif poured the soup into the bowl at a constant rate of 5 cm cubic per second, at what rate is the level rising if the depth of the bowl is 10 cm? So, first question is we wanted to find the rate of change. So, which is dx dt, because value of 10 is the depth of the bowl. Depth of the bowl, by referring to the main question, indicates the value of x. So dx dt when had been given the value of dv dt. Second question is, if his brother just eat half of the 10 cm depth with decreasing 0.001 cm per second, what is the constant rate of the soup lost from the bowl? So basically this question is just the reverse for the question 1, because for the second question, we wanted to find the constant rate, which is dv dt, when the dx dt had been given. So that is for question 2. For question 3, determine the volume of the soup left if Akif's brother spilled 1/4 of the soup. So basically all these 3 questions will refer on the main formula right here for the volume. Moving to the next slide is the objectives of the question. So the first one is to find the rate of change when the depth of bowl is 10 cm. Second one is to find the constant rate of the soup lost from the bowl. And the third one is to determine the volume of soup left after spill. Moving to the solution. So this is the diagram that I have sketched because after I have read the question just now, it has stated that the shape of the bowl is in hemisphere. So this is what a hemisphere shape looks like. And I had labeled some of the information given from the question. For example here, R indicates the radius of the bowl, which is 30 centimeter, and depth of the bowl is x centimeter. For the first question, we wanted to find the rate of change when the depth of the bowl is 10 centimeter. So basically we wanted to find the value of dx dt when the value of dv dt had been given in the question, which is 5. So I had applied the chain rule method, and by using chain rule, we must to formulate an equation to get the answer. Dx dt is the value that we wanted to find, equals to dv dt had been given in the question, which is 5, times with, how did I get this derivative, is because I want to cancel out here dv and dv so that I will get the exact same dx dt like the left side. So both of the side will be the same derivative. So here dx dv is actually the differential of volume with respect to x. So here is the original equation formula for volume, which is 1 over 3 pi 36 x square minus x cubic. And after I had differentiate v with respect to x, it will be dv dx equals to 1 over 3 pi 72x minus 3x square. So this is how I differentiate the value of x, which the power in front here, the power 2 will times with the number in front of x, which is the 72x. The power will reduce 1, and the same goes here. 3 will times with the number 1 in front of x here. It will be 3, and the power will reduce to 2. So after I differentiate, I want to substitute into the formula, but I cannot because of this is the derivative of dx dv, but this is dv dx. So I need to switch the formula first, or the equation first. So that means dv will be down below and dx will be on top. Switch the position of the fraction. So the equation will also be changed from pi 72x minus 3x square over 3. It will be 3 over pi 72x minus 3x square. So the value of x, just substitute with 10 because it had been given in the question, and 5 is the value of dv dt. And after we had multiply them, the final answer will get 0.011 centimeter per second. I forget to mention the reason why I just copy back the value of 1 over 3 pi right here after I had differentiate v to the with respect to x, because of pi is just a constant value, meaning that it doesn't change with respect to a variable. It will graph as a horizontal line, just like as we know slopes of a horizontal lines are zero. So the derivative of a constant like pi will always be zero. We continue to the second question, which is to find the constant rate of the soup lost from the bowl. So actually we wanted to find the value of dv dt when had been given the value of dx dt. So I just copy back the exact same equation from question 1 to find the answer. So here dx dt equals to dv dt times by dx dv. We wanted to find the value of dv dt, so just bring this derivative to the left side, which means dv dt equals to dx dt divided by dx dv, or I change the sign of division to multiply here, so that means dx dt will multiply with dv dx. Dx dt had been given in the question, which is 0.001. So just substitute the value times with, here dv dx is same exact like question 1 after I had differentiate volume with respect to x. So it will be like this. pi 72x minus 3x squared divided by 3. Same like this, pi 72x minus 3x squared divided by 3. And then I substitute the value of x with 5 because the keyword is right here. Eat half of the 10 cm depth. So that means half of 10 is 5. So just substitute 5 here and the final answer we will get is 0.298 centimeter cubic per second. Lastly, for question 3, we wanted to determine the volume of the soup left if Akif's brother spilled 1/4 soup from the bowl. So here I am using the original formula for volume, which is 1 over 3 pi 36 x squared minus x cubic. And then I substitute the value of x with 5 because in the previous question had stated that if his brother just eat half of the 10 cm, that means half of 10 is 5 cm. So the remaining volume of the soup in the bowl after his brother had eaten half of the soup, it must be another 5. That is why I replace the value of x with 5. And then I calculate the value of volume first that is left. And then the question had asked me to find the volume left again after his brother spilled 1/4. That means I just take 1 over 4 times with 811.58 centimeter cubic and I will get the volume of the spilled soup. And then just take the original or the current value of volume left minus with the volume spilled, and this is the answer that I get for the for the volume after spill. As conclusion, the volume formula of a hemisphere is V equals to 1 over 3 pi 36x squared minus x cubic. For question 1, the rate of change is 0.011 centimeter per second. For question 2, the constant rate of the soup lost from the bowl is 0.298 centimeter cubic per second. And finally, for question 3, the volume of the soup left after spill is 608.63 centimeter cubic. Then that is all from me. Thank you, sir, for watching my video and I hope you will satisfy with my explanation. Thank you very much. Assalamualaikum.